Hi everyone! Today we will discuss the difference between planetary and spur gearboxes, and gearboxes with different ratios. There are also video comparisons, but I decided to put it in a different video, so that this one won't be too long. We have here 3 different gearboxes, and I wanna start by comparing the planetary gearboxes, that's these two, to the spur or normal gearbox, and that's this one. Let's see how it works inside. This is the classical gearbox system where the gears are connected in series, meaning that gear 1 turns gear 2 and then gear 2 turns gear 3 and so on. However, this puts more pressure one single point, because each gear is connected just by one point to another gear. And this makes it less reliable in high load scenarios. But because they are simpler, cheaper and lighter and also smaller, they are used in less demanding applications where a high speed and high torque are not needed. This is the planetary gearbox, and I decided to print a system of how it works because I was too afraid that I wouldn't be able to put the normal one back in place. The gears in planetary gearboxes work in a unique way. They have a middle gear, also called the sun. The sun gear drives multiple planetary gears, usually 3 of them. They are held in place by a ring, across which they turn and travel. The ring is fixed in place, so it doesn't move at all. There is also this component which is called a carrier. It also holds the planet gears, like this, and it can have a output shaft on top of it or another sun gear. And this is how you create another stages. You just add another sun gear on top of it and then just go up until pretty much until you want. Since the sun gear contacts with multiple, or in this case 3 planet gears, it is compared to spur gearbox, which only has one contact point. It is better suited for heavy loads, and because they have these 3 contact points, they better transmit energy, so they are well suited for high torque and high speed applications. So for OV I use these 2 gearboxes. This is a 1:50 ratio and this one is 1:14 ratio. I decided to go with planetary gearboxes because they are more energy efficient and they are well suited for high speed and high torque applications, which is exactly what I need. The 1:50 ratio is slower, and it means that for every 50 turns the motor makes, this big wheel turns once. It's approximately 4 times slower than the 1:14 ratio, but also has 4 times higher torque. And because it's slower and has higher torque at low speeds, it is better for precision tasks like indoors, autonomous navigation, lawn moving and high torque applications as well. But we'll get into those details later on in the video. The 1:14 ratio is faster, 4 times faster, but has 4 times less torque. But it has a higher energy efficiency because it has one stage less. As you can see, it is slightly lower. And there are some problems with mainly precision with this gearbox, but otherwise it's really fun to control it, especially outside. So, how do you actually mount the gearbox onto the ROV? Firstly, you have to choose which gearbox you wanna use. We are gonna choose this 1:14 ratio gearbox. As you can see, the motor has a gear attached to its shaft. this gear will go right in here. Yeah, right in the center, and it will be turning the other 3 gears. Alright, so let's gently put it there. After that you just add tracks and you're done. The video comparisons are in a different video, but you can click on it right here.